good evening, everyone. Thanks for coming. Today I'm going to talk to you about my research into breast cancer. And specifically, I'm interested in why breast cancer spreads throughout the body the way it does. Breast cancer is unusual in that it can spread to a wide variety of locations in your body. And as a result, it can produce a wide variety of complications. Now, the good news is fewer women are dying from it these days, but the bad news is it still produces an enormous amount of harm. Now, every year, tens of thousands of American women succumb to the worst complication of breast cancer, when it spreads to the skeleton. It's incredibly painful and even causes spontaneous fractures sometimes. In fact, this event, when it starts to degrade the bone specifically, this is the #1 cause of harm for American women with cancer, period. And despite the fact we know a lot about how this happens, the mechanisms that enable it to disseminate from the breast and colonize distant tissues, despite knowing how, we've never understood why. Why does this manifest? Because if we understood why, maybe we could come up with new strategies to prevent it from happening in the future. Now, there's a feature of breast cancer that everyone in this room is familiar with. Breast tumors are stiffer than normal tissue. That's how they were first discovered, and how they're still discovered even today. It turns out breast cancer cells behave in peculiar ways in stiff environments. You can see breast cancer cells in glass here. They seem to reach out and pull on their environment. We've known for about 10 years that when cells do this, when they can pull on a rigid environment, this actually initiates a communication relay inside the cell that culminates with the cell changing its behavior. Our central question was, what behavior does this change? Does this instruct the cell to go to the bone? If we remove the cells from a stiff environment, it's not going back. If we remove the cells from a stiff environment, return to a soft environment that mimics healthy, normal breast tissue, if we block that communication relay, what will be the consequence? This was actually easy to test. We extracted a tumor cell from patients, separated them, grew half on soft, that mimics healthy, normal tissue, half on stiff, that mimics unhealthy tissue, introduced them to mice, and watched. And it was really remarkable what happened. The same tumor can be rendered virtually harmless when coming from a soft environment, or incredibly destructive when coming from a stiff environment. This is really exciting because it points to a potential new therapy, one that doesn't even target the cancer cells directly. There's already drugs that prevent tissue stiffening, but up till now, no one's proposed using them in cancer therapy. This discovery provides the rationale to repurpose these existing drugs to now use them in cancer therapy, to prevent tumors from getting stiffer, prevent them from going to the bone, and ultimately prevent the harm that they cause. Thank you.